Okay, we are back.
Wow.
Hello, guys. So it's 3 o'clock. Well, a few minutes past 3 o'clock. And we are going to start our workshop proper. But in case you were confused by the videos that you just saw, those are videos to explain how to use the microbit with components. We have planned a whole series of videos with different external components, and we are posting that on our YouTube channel, Think Academy. And we will perhaps give you a link later if you are interested in that. But what we're going to be doing in this hour is we are going to be building a lightsaber, and we'll be working with the WS2812 light strip. So I'm Akmal, and that is Ben.
Hey guys. Hi. Nice to see you. Thanks for joining us on Sunday.
Yeah, sure.
Yeah.
On a Sunday, yeah, that's right. And together, we are gonna bring you through this workshop. All right.
Yeah. Pretty cool. Yeah. I'll start first, okay? I'll start first.
Sounds good.
Yeah. This is a series, right? So it means like the people who join us would have already been coming in for a couple of weeks. Is it like even around a couple of weeks of this has been going on?
They've been doing various make it workshops, but some of them have been microbit. Some of them were 3D modeling. It could be, I'm not sure what other kind of workshops that they have. It could be robotics, for instance.
Okay.
This is a whole series of workshops, but it's a different theme in each one. So for us, I think we are doing this one, microbit, and we are going to be doing another workshop later in the month, the one that Tracy is doing with the motos.
Okay. So it's like a bit onto this week's workshop. Okay.
Mhm.
Sounds good. Okay. Anyway, yeah. So like, hi guys, my name is Ben. And Amal has already introduced me. So I will start off the workshop today by talking a little bit about the microbit, and then there'll be a little bit of hands-on because I think like me and Amal will figure out like if you guys sit here and watch us do stuff for 1 hour, I think you guys are gonna tune out within like 20 minutes or
Very
before,
much so.
or much earlier. I cannot imagine sitting around and watching people make stuff for 1 hour, man. That'll be like a bit long drawn, man. Yeah. So we're gonna make this at the end of this workshop. By the end of this workshop, Akmal will have this little lightsaber in his hands, and if you follow along the lessons, or you follow along with the things that we're gonna do, you will have the code to actually make the stuff, right? So you just have to put the physical stuff together and download the code into your microbit, and the additional parts, and then you will have a lightsaber as well. Okay, so like information of how you can get the parts or how where you can get them, we'll share with you in a while, right? I think it should be in here somewhere. Okay, I'm gonna move on because now we'll run out of time. Yeah. So the next slide. Okay, as you can see, it's the introduction of our company. So
sorry.
Yeah, sorry, Amal.
You're a little bit because the screen is a little bit small. Do you think you can screen the presentation?
I can. Let me find the full screen button. It's not present.
Yeah.
Not full screen. Is that better?
Yeah, maybe I should full screen this one also.
It's me, right?
You don't need to see our faces.
Yeah, I know. But I mean, is it me or is it you?
Right.
So this is good, right?
Because of the text is a bit smaller. Should I make the text bigger?
Yeah, okay.
Anyway.
I think actually the purpose of this slide is not for them to read the text, it's for them to see the link at the bottom here. Okay, so guys, if you can see the text, great. If you can't see the text, right, then go to the link called Tinker Academy, tinkeracademy.com, right? So take note of the spelling, right? And this page will actually give you information of the education arm of our company. So what we do for education and the kind of different courses and different components that we play with. Yeah, so we've been around for quite a number of years already, and it's pretty cool. Got pretty cool courses going on out there. It's all on our website. If you need any information, just DM us at the end of this workshop, and our back end, our guys can actually fill you in more information. Right? I'm also going to fill in the information, right?
Yeah, sure. Happy to get contacted.
Here. Yeah. Next is okay. So this is the book that we recently just launched.
Well, yeah. So we just wrote the book. We've been teaching microbit for a couple of years now, since it first came out, and we decided to put all our knowledge about the microbit into a book. This is the book that we have. It's a bit glossy, but yeah, I'm holding out the book to the screen. So it contains, yeah. So it contains a lot of knowledge. It starts off with the basic knowledge of microbit, but it goes very quickly to the basics so that it can focus on how you will attach external components to the microbit, because even though the microbit has a lot of components on board, right? The accelerometer, the compass, the radio, the LEDs, we can do even more if we are able to connect external components to the microbit. So that's what we focus on in the book. Yeah.
Yeah, very cool. And I think those videos are like part of the, supposed to be part of the book as well, right? So like the video series that.
Well, actually, I have a video that I can show later on that shows the light chapter, and that's why our the project that we are doing today actually comes from the chapter in the book. I'll show you the video, that short video, after the next few slides before we start on the Lightsaber project.
Okay, I think it'll be good. At least you can see the thing from the videos as well. Okay, I'm going to move on here, right? I'm not going to stay here already. Okay, yeah. So anyway, the next part is like if you're interested to get parts for your the projects you will learn this week and the next workshop, you can head over to gethacking.com, right? There's always promotions being run, and it's like you can earn points and stuff like that if you continue to buy stuff on this site. But basically, you can get all your components that you need for this workshop and for many other things that you want to build, right? Okay, so just head over down to this website, right? It's very good. It has very cool. It has like everything you need, right? And it's always updated, and there's always new stuff coming in, right? And look out for promotions as well, right? Yeah, I think that's about it for the Get Hacking. Do you want to add anything more for this?
Nope, I'm good.
Okay, so I'm going to leave it here for a second, so we can see. All right. So take a photo of the link if you need the URL. Okay, next, if you need to follow us, if you want to follow us on social media, you can follow us on Instagram, right? We are always posting our new products. We're always posting like projects or things that we make, and it's always going to be there. So if you want to get inspiration or you want to like see what's happening in the maker community, right, you can head down to our Instagram, right, page, and yeah, that's where you can get up to date, stay up to date with the things happening, all right? Especially courses. I think courses go on there as well. Do they go on there? They do, right? Sometimes we post. No.
Let's Get Hacking just post projects that we find interesting.
Okay.
We make it projects and we'll post it on the Let's Get Hacking Instagram account.
Then the courses will be Tinker Academy, the Instagram page. That's the other one, right?
Yeah. Those are elsewhere.
Okay. Yeah. Anyway, this is more pertinent for this course workshop. So like this is the one that you should follow. All right. Moving on. Okay. I think that's about it for our marketing and stuff. Like if you want to find things about us, right? We're gonna start off the lesson objectives, so that you guys can start making stuff. So, okay. So for today, as Arman has said, we are going to build that lightsaber thingy thing with light strips, cardboard, right? The microbit and breakout board extension. So the breakout board is actually another component that you probably have to get to add on to the microbit, because as you know, I think I'll be very surprised if people have not actually touched the microbit, because it's been around for quite a few years already. I think like this is the third year it's been around. Second year?
Yeah, but I think we do live in a bubble where everyone I know has heard of the microbit, but everyone after that not. Yeah, but everyone that I don't know, I think there's still a lot of people out there who have not heard about the microbit.
Okay. Yeah, wasn't NLB giving away microbits for a period of time? Like I thought they were like giving.
They were in the first year of the Digital Maker program. If you signed up for microbit workshops, if a member of the public signed up for a microbit workshop, you will get to bring home your microbit. Okay. But that was that program has ended.
Oh, okay. So basically, no one's able to get any free microbits anymore. Like now?
No more. That program has already ended. Yeah.
Okay. Oh, okay. Okay. Oh well. Oh. Okay. So I thought it was more rampant. Yep. Sorry.
So before we actually start on building the Lightsaber project, as I mentioned, this project comes from this book, right, that we wrote, and it came from chapter 8. It comes from chapter 8, which is the all the chapter all about lights. So let me show you a brief overview of what's in chapter 8 of the book.
Hi, welcome to the Tinkerer's Guide to the Microbit Galaxy chapter review. What we have here today is chapter 8 of the book, and this chapter is called Lights, Loops, Lists. Chapter 8 is a slightly advanced chapter as it is expected that you already know the basics of microbit, MakeCode, and how to plug in external components as well as programming concepts like variables. If you are a total beginner, not to worry at all. This chapter, or in fact the whole book, will guide you step by step. As you can see from the title, this chapter has 3 overarching concepts. The first one is lights for function and aesthetic. Next is loops to repeat certain sequences. And lastly, lists to store an ordered sequence. Also, there are 4 projects in total, ranging from using lights for functional feature like this Snap the Dot game, or using lights for aesthetic purposes like these bling bling bracelets, or better yet, using lights for both its function and aesthetic, just like this night light. Speaking of night light, here's a short demo of how I built the project following the instructions from the book. Mastering how to code for a simple LED strip and knowing the concepts of loops and lists are the foundation blocks to program other types of LED displays such as the LED matrix and ring. We have done many projects with just these 3 concepts, and I'm sure you can do the same too.
Alright, so there we have it. That's the chapter 8 of our new book, which deals with the light strip. So today we're going to be building specifically the Lightsaber project.
Yeah.
Okay,
it looks quite good. So yeah, back to me, right? Yeah, okay. So
yeah.
Because so it's about the same thing as what we're going to do is that's listed on the slide. So basically, you're going to use the NeoPixel extension to control an LED strip. So the LED strip is the one that you saw in the video. So it has like multicolor. You can control the light colors. You can change the colors, right? And once you plug it into the microbit, you can even control it with your motion, like if you swing it around, if you press buttons and stuff like that. So it makes it a little bit more functional. But by itself, I think the LED strip is just an LED strip without the microbit. That's what makes the microbit so much more, the combination of the microbit so much more fun and useful. And on top of that, I think like if you are watching this video and if you are doing this, if you want to do something with your kid or learn to make something with your kid with a little bit of coding involved, right? This would be like quite a good fun project to do. Okay, at the end of the day, you get to see something and it gets to react with you. Right? You can even add sound if you will have if you have enough time. I think there will be a little buzzer section that we can add on as an additional part of this project. Yeah. Okay. So got to be mindful of the time. And okay. All right. So concepts that we'll be talking about will be like the accelerometer, right? Pronounced it correctly. Conditionals, which is a programming concept which we will talk about in a short while. Music functions, which is also a programming thingy that we will look at in the MakeCode portion. Then the LED strip functions, and then as well as the custom functions. So we basically be building our own functions. So if you are joining us today and you have never ever touched the microbit or done MakeCode before, hopefully within the first 15 minutes we should be able to show you how the programming interface works, where it is, and then like what are some of the basic ways to move things around, to put things together, and then you should be able to learn it by yourself in the future, right? If you have not done it before. But if you have touched microbit before and you've done MakeCode before, this stuff should be quite really quite easy for you, right? Right? It shouldn't be that hard for you, right? You've done it before. Yeah. But if you've not done it before, I think you might struggle a little bit. But don't worry, it's not that hard. It's like a little bit hard to pick up at the beginning, and then it gets really easy.
I mean that's part and parcel of STEM education and maker education, is that you don't just follow steps and then at the end of it you get something and that's it, right? You want to struggle a little bit, figure things out when things are not working. You're figuring out like, okay, what went wrong here, debugging it. And at the end of the day, when you finally get your project with a little bit of struggle, that feeling of achievement is a lot more. Like,
Yeah, yeah.
hey, I built this, and it gave me so much trouble, but I did it. Yeah.
Yeah, I agree, man. And I think the thing about like programming, I think like from my experience, I don't know whether it's the same for you. It's like I think it's really hard to learn at the beginning, but once you get a hang of it, it's like it just clicks together, and that's where the fun part begins. Because once you actually, it becomes easier for you. Once it clicks, it gets easy for you, and that's where you get to make lots of stuff. And you can actually cross. The skill is actually like what's the word? You can bring it across like different platforms. Cross applicable. I don't know what's the term. Like you can transferable skill, right? You can transfer
transferable skills. That's right.
Yeah, there's a education term for it. I don't remember what it is now. It's one of like the theories.
I don't know. I don't remember.
Yeah, I don't remember either. We both feel our education psychology and all. Okay, moving on. Okay, supplies that you need. Hey guys, so if you're watching, you definitely need a microbit, and if you haven't gotten the free one from NLB, well, if I'm not wrong, there are going to be some competitions out there where some organizations are going to give up microbits. You should keep a lookout for it. So I do hear a win of it in that some competitions will be coming out in the future, right? You need a breakout board, which you can buy from us on the Get Hacking store. Or if you want to, you can even go to SimLim Tower. I think there's a store at the basement that sells it. I think it's called Continental. I don't know. I think so. And and then the strip module, the WS281210 LED. That's the NeoPixel strip module, right?
Yeah, that's right. So the technical name is WS2812, and actually it's the whole family. That's WS2811, that's WS2813, that's WS2812B. They all come from this company. I guess different models. They've improved it. Every new iteration, they've improved on it. But what happened is why we call it NeoPixel. Normally it's because obviously who wants to remember WS2812? But NeoPixel is a brand. It's a brand name for this module that was created and trademarked by the company Adafruit. So Adafruit is a US company. They trademarked the name NeoPixel. So NeoPixel is a much more marketable term than I'm going to sell you a WS2812. No, I'm going to sell you a NeoPixel, right?
Hey, hold on, I'm sorry. So only this particular model works with the microbit breakout board, right? This particular one. The other models won't work,
right? No, they might work too, depending.
Okay, but you do.
But we are not. We haven't played with them enough to say either way. But we do know this WS2812 will definitely work with the microbit.
Okay, so guys, if you're going to get the LED strip, get this one. Then if you want to try other ones, message us or DM us, and then I think I will get our engineers to like tell you whether you can work with the other strips. All right. So to be safe, just buy this one. All right. Okay. Then of course the other thing that you need is the make code, which is in the web browser, which is free. So you don't need to buy or pay or find the coding platform. It's online. It's by Microsoft. I believe it's by Microsoft. Yeah.
Yep. Yeah. It's by Microsoft.
Yeah. So it's up there, and you can just use it. Okay. We'll be using lots of the make code program in a few seconds time. Then of course for prototyping supplies, you need the breakout board, which I said you can purchase online from us or SimLim. You need cardboard and you need tape. You don't have to use cardboard and tape. You can use anything you want. Basically, once you know how to make this project, just knock yourself. You can even use like your metal ruler or something like that. I don't know.
Yeah, you can.
Yeah, so that might be fun. And I think you can use rubber bands and things like that. Okay, let's move on. Anyway, I think this is recorded, so they can actually back scrub to the other thing.
Yeah, they can.
Okay, so access from web browser. So the first part now we're going to do is we're going to play around with some basic blocks on your on the microbit programming platform. I would like you, if you want to follow along and not watch us code, I would highly encourage you to go to the website URL that I have on screen now. Go there and type it into your address bar, and then let it load. And then once it's loaded, you can actually put your screen beside, because it's quite big, right? Like maybe minimize your screen a bit, or watch the live stream on your phone or something like that, and code along, right? I think you can even use this on your phone if I'm not wrong. A bit.
Yeah, you can. It's kind of the screen's a bit too small, but if in a pinch you want to be coding and make code on your phone, sure you can give it a go.
Yeah, yeah. I have students who like sometimes they just bring their iPads and they do it. Yeah, and then if you don't have a microbit, the good thing about this coding editor is for the very basic stuff. If you notice on screen, there's this little microbit here. So whatever you do will actually have like some digital what do you call feedback, as in you will be able to see the effects on the digital version of the microbit here. All right. Okay. So you can actually see some things happening. So it's not like you code already and like, hey, nothing's happening, man. I don't even know what's happening. But actually, for this particular programming platform, they give you a digital version of it. So if you don't have a microbit, you can actually see what's happening, and then you can go buy your own microbit next time in the future, and then you can see the real thing in action. All right. Okay. I'm going to move on from here. I'm going to exit from this slide, actually. I'm going to go to the real platform. Yeah,
sure.
I don't want to use the slides for a while. And then if I miss anything later on, we will come back to it. I think later on, right? I just want to show
yeah.
All right. Okay. So this is my make code, and for some strange reason, my microbit is great. Why is it gray, man? Okay, let me hold on. Oh, there's color. Let's move it.
Oh, right.
Okay. Now it's working. No, it's not working again. Okay. Let's pause it. Okay. Yeah, mine's blue. I wonder what color is yours.
It's okay.
Yeah. Okay. So if you're following along, right, you should see the same screen as me, right? I'm using the make code editor in my browser, just like you, and this is the interface that you will always have. And if you are following along, sorry,
Ben, hang on. Yeah. Can you just zoom in the bottom right corner? There's a plus button. Zoom in maybe
this part here.
Once or twice with the box. Okay. Maybe the one is a bit big. Yeah, that one's enough. Is it too big?
Shall I zoom out?
Yeah. Okay, this is okay. Yeah.
Okay. Yeah, look at my screen, right? Not the Facebook feed, right?
I'm looking at
my screen. Okay.
Yeah.
Okay. So I zoomed in, so it gives me quite a lot less real estate. But basically, if you can't see the code later on, don't worry. Okay, we'll like zoom out at the end of it. Okay. So anyway, this is the interface that you look like. I wanted to like give a warning first to people who have done microbit before. This part is going to be very boring for you because we really are. I'm just basically going to teach you, or not teach you. Teaching is like not the right word to use. I'm going to show you. I share with you what the different where the different blocks are, how you get the blocks, how you click and drag stuff. Like maybe make some funny smiley face here. Talk a little bit about loops and talk a little bit of logic, right? So if you have no programming background, and stuff, just listen. If you have any programming background, this stuff you can just tune out a bit, maybe go make yourself a cup of coffee and come back in 2 minutes or something like that. All right, okay. Or you can go and explore the JavaScript portion if you want, because you can code in JavaScript as well, right? If you want to, for those adventurous ones, just click on the tab here. Okay, so this is interface. The top bar is a menu bar. You click on home, and you click on home, they'll bring you out of the editor to a place where you can actually look at other people's project or your own projects. We will not go there. You can click on share. So if you, after making this project, or after coding something and you want to share it with your friends, right? If you make a project, hey, I made this code, use it, click on share, and you can send it to them via WhatsApp or Line or whatever messaging platform that you use. Then up over here on the top, you have blocks and JavaScript. So these two little buttons here allow you to choose between coding using blocks, which is what we have on screen here. These are blocks because they look like blocks, right? And JavaScript, which means that if you are the kind of person who prefers to type in code, then you can do this. But you probably have to go read the library APIs or rather the documentation for the code, because I'm sure there are a lot of functions in here that are not very plain vanilla JavaScript. Okay? All right. Feel free to jump in if I'm missing anything, because I'm sure I'm rattling on just to save time already. Okay, so based on this screen, right, the microbit screen, everything is in drawers. So like I said, you have the digital version of the microbit here. So anything that you code will immediately reflect here on the digital microbit. So for example, if I were to go to my first column, my first drawer here, right, category called basic, there's a whole bunch of blocks in here that can be used of. And how the make code editor works is I drag out the blocks that I want. For example, I choose show LED, right? So show LED will basically allow me to show stuff on start. Okay, so there are two basic blocks that are by default shown when you first launch a new project. One is on start and one is forever. Okay, so if I want to like make anything appear on screen or make anything work, I have to put them within these two blocks, right? Because this is like your initial entry point into the program. Okay, so I put it on start. So basically, when the program starts, when I connect my microbit to a power source, because the real microbit actually is a microcontroller and it needs power. It doesn't run on solar or anything like that. So you need to connect it to a power source. So once you connect to the power source, it will power on, right? And then that's when it starts the program for you. So on start, it will show whatever I want to show on LED based on this little block here that I've created. So if, for example, I want to like draw a little square, right, like this, does it look like a square? Okay, right. Every time the program starts, it should show. Okay, like this. There, I got a little 0. So you can actually make a scissor paper stone game very easily, off the bat, right, using the blocks. Okay, but of course there'll be a lot more blocks involved. And then of course, if you want, for example, to not just show one LED, for example, let's do icons. Put icons in here. Okay, so on start, I'll show a heart, and then I'll show a square, right? Okay, it will run pop up like that. Okay, but the thing is about the on start block is it runs once only. So like on start, I'm going to run the icon block, and then I'm going to run the LED block. That's it. It's over. The program has finished. Okay, if you want this program to run eternally until your battery runs flat, put it over in the forever block right over here, and then this is a loop. So if you're not familiar with loops, right, it's something that goes over and over again, and it repeats itself over and over again, right? You just put it in there, and it repeats itself. Like what's happening on my screen now? It goes looping within a heart and a square. Yeah, no symbolic meanings there. All right, okay. Moving on. Okay, moving on. Right. There are blocks for buttons. So for example, you notice that my microbit comes with buttons. So there's button A and button B. So you can actually pull the input under the input category. You can pull out the button block, and you put this in here instead of the forever block. And now whenever I press button A, it will show my heart, right? It show my heart and then the square, right? Okay, I can of course change it to button B, and then button B here, and then instead. Okay, so there's some very basic functionality that the microcontroller comes with. Yeah, so that's a good thing about microbit. It comes with like some built-in functions, and it makes it easier for you to do things. So you don't have to like extend it at the initial stage of your learning of the microbit. But of course, as you progress through learning to use the microbit, the things that you can do with it are quite limited. That's why there's other things that you have to buy to add on. It's like buying add-on parts to your car or whatever they are using, and you want it to go faster, you want it to fly or something like that, and you buy more parts, right? So the basic bit, like the basic functionality of microbit is limited to just buttons and shakes and accelerometer and stuff like that. Okay, moving on. Inside the input column, you have all this. So if you scroll down, like, oh, hey, what's all this accelerometer, pin, light, 0, right? So for 1 hour workshop, it's really pretty much impossible for me to cover everything. Just know that anything to do with getting input from you as a user for the microcontroller you should be able to find here. For example, if other than buttons, if you go to the second block down the column, you see the on shake. That's the one that allows you to do stuff other than pressing buttons. Right? So if you click on the drop down this box here, oh wow, they changed it. Now they have logos. Okay. So if you click on the drop down this box, you have shake, logo up, logo down, screen down, and stuff like that. So these are the things you can do with the microbit to elicit a response from it. Okay, so inside this block here, I can put in like show a number. Well, this can be a dice already. Okay, and then so let's
random math.
A random, yeah, but we're not gonna show random yet. No time. So let's always show a lucky number. What's a lucky number? 7. Is 7 lucky number? I don't know. What's a lucky number, man? For everybody, 8. Yeah, 8 show 8. Okay, so every time I shake the microbit, it's going to show 8. So once I have this block here, there's this little thing called shake here. Because it's a digital microbit, I can't shake it, right? But I can actually, I don't know how to do this, man. Shake. What am I supposed to do? Click on it.
Click on.
Oh, okay. I didn't notice it. I thought you're supposed to do this with your mouse and then you shake.
You can also.
Really?
But you need to be a lot more violent.
Oh wow, I can't manage my mouse is got
so we set the simulator. We set the simulator with the and then now shake your mouse violently over the
that's true.
Yeah.
Oh, they have gotten a lot more. That's pretty cool. Okay. Yeah, so shake, you can shake, and then you can actually throw it out a window. Don't throw it out a window, guys. Yeah, and then you free fall, and then you can record how much G-force. I think you can record how much G-force is being applied to the microbit, right? I never tried that. No. Honestly, I always tell my students that, but I never tried it. Yeah. So I think
you can get to. So basically, all these events that you're seeing here, it's basically processing the accelerometer readings into a higher level event like shake or logo up or logo down. But you can also look at the raw accelerometer readings. Can you show them the raw accelerometer readings from the input drawer?
Input drawer. I saw it just now. Yeah. It's like the little this one.
Yeah, that's the one. Yeah, that will give you the raw readings, and then in the X, Y, Z axis, and
it's a number, right? It was just a number, right?
It will be a number. It's measuring.
Oh yeah,
It's
then you can
giving
actually
you the.
pop it into here. The show number.
Yeah, you can.
Let's do that, man. Oh, cool. Yeah.
Well,
so XYZ
I don't
and
know
strength.
what will happen in the simulator though.
Okay. I don't know.
In the
What's
live,
strength? It's like the total combine of XYZ combined together. They do a formula.
Yeah, that's right.
That's
That's
the
right.
strength.
That's the combination of XYZ vector. That's
Oh,
the
it
strength.
really does show a number. Fuck no.
So it's showing you the value for the acceleration that we are
So-
feeling,
Okay.
the force that we are seeing. Basically, gravitational force is pulling on us. So it's about on Earth is about 1 g.
Okay, so the one that I see now is not because I'm shaking the microbit, right? It's because there's like that's the official gravitational pull on us. The number of
Yeah,
newtons.
that's
Okay.
Yeah.
That's cool. Okay, so guys, just remember, like, if you want to get like how much force you're using with from your microbit, this is the pill. Little pill. I call this pills. I call it pill because it goes into the little sockets like this. I like call it pills. And then when it goes to the pop, and then like run. So these pills don't run by themselves. You can't put them into like this little jaws like this. They won't work. Okay, they need to go into the little pop sockets like this, like show number. Okay. All right. Okay. I think we'll talk a little bit more about the accelerometer later on. So I don't want to talk about it. Just if you need to know, guys, later on, like where to find it, it's all in the input. Okay. And then if you click on input and there's a little purple color thing called more there, there's even more like funky stuff. Oh man, magnetic force and stuff like that you can pull out and you can make use of those information like running time. Oh wait, not running time. Don't talk about running time. Rotation and magnetic force. So the rotation one is actually quite useful as well because you can measure how tilted you are on one side of the microbit compared to its relative horizontal position, right? That's the one, right?
Yep. That also uses the value from the accelerometer.
Yeah, so that's the thing. And then below there's the accelerometer range below here.
Yeah. Should we go into the accelerometer in greater detail and move on to the Lightsaber project?
Just one more thing, because you will talk about loops later on, right? So like I want to show them where to get it from.
Yeah, sure.
Okay, so like so I think the next important thing that you will need to play with today is loops. So it's over here in green above logic. So if you need to do a bunch of stuff that do loops for you, like repeat something a designated number of times, right? You can use the repeat here, or you can use a while something is true, and then you use conditionals to control it. So the condition is something that allows you to check whether something is true or whether something you want to do is work. And that's important for today's lesson as well. So under logic, later on, you'll be using some of this under logic, which is the if, then, else statements. So if you've done programming for this, it's like, oh, hey, I don't have to code it out, just drag it out and I can use it like this. On shake, if something is true, then I'll do something, right? So this part here, you probably need to find from the logic column here, which we will make use of in while, okay? Like this. Just remember that. And the pills actually go into all the sockets if you need them. Okay, I'm going to go back to the slides because I think we are already running out of time. Where's my slides? Okay, so that should have been enough of a teaser to the main thing. Guys, if you need help, with the basics, right? The book will cover a lot of the basics. I write the book that we made.
It will.
So just go through the book, or you can actually DM us, and then we can hook you up with a course.
There are tons of amazing free resources out there for learning how to use the microbit. That's for sure. Yeah, especially from Microsoft itself, Microsoft Make Code, and from the Microbit Foundation, they have created a lot of learning resources on how to use the microbit.
So I think you're not sure. It's easy to learn. Just go watch the videos, and then I think within a few hours you'll be able to use the microbit really well, right? And then you can think about what kind of things you want to make the project. Okay, so back to the slides, right? The problem statement is we want to build a lightsaber project, and we're going to use the microbit to do it. Okay, so let's break down the problem statement, right? Because when you want to build something, you can't look at it from the big picture. You need to break things down, break problems down to the smaller components, and then start from there. Right? If not, it's going to be hard, right? Basically, you can't solve problems by looking at the whole picture. You need to look at the individual components and make out a problem and solve it. Okay, so what do we want to do? We're going to shake the lightsaber, and when we shake, the LED strip is going to light up for a short while and perhaps make a sound, or maybe the LED strip is going to do the spiral thing, or maybe it's going to do a dot light show for you. I don't know, man. I'm sure those things are possible.
It's up to you. It's how creative you want to be with your light show. But I just want to add on the whole breaking down of the problem statement. Is the process is also formally called decomposition. And decomposition is one of the core skills of computational thinking. Computational thinking being like, how do you solve a problem, thinking of it from the way that the computer will look at it in a very logical way. So if you have a huge problem, decomposition means taking that huge problem and breaking it down into solving smaller, easier subtasks that we can solve, and then putting it all together to solve your bigger, complex problem.
Yeah, that's one of the main things that we always highlight in our lessons. I think for our school lessons, right, or like even for our basic coding lessons, I think decomposition is one of the first concepts that we always talk to our students about. Right, one of the more important things that we need to learn, and it's very cost applicable. Again, I need to find out what the term is, man. It's very applicable to all your other areas of life.
Transferable.
Yeah, like every problem in life, you really have to decompose it. You can't just solve a problem without decomposing it, man. Like it's virtually impossible. Okay, moving on. Okay, so we showed you this block before already. So one way to use this, like for example, we want to build the lightsaber, right? So obviously we have to either press a button to make the light appear whenever we shake it, or we can use the on shake block, which we saw just now. So every time we shake the microbit, it will trigger an event, right? And an event is like something that happens when you do something, right? Okay, so this is built in for you. I think like I remember in the past when you want to code like very simple stuff, right? In the code, this kind of things like you like the on sheet will be a tremendous coding. This by itself is a task, right? This is a monumental task by itself. But I think like with the libraries, you just click and drag and you get it to work, right? So use this block, and then from there we start building. So we shake and then something happens, okay? And what we can explore is the accelerometer. Yeah, sorry, I'm saying.
Yeah, but we don't want that for this project. Right?
Yeah,
it requires quite a big shake to actually trigger the on-shake event. So we want something
else,
Yeah, we want something a bit more sensitive to motion, so that when you swing the sword around, it's not really a shake event, but we want to be able to recognize that. Yeah.
Okay. And the hint is like we talked a little bit about it just now using the accelerometer pill, right? How much strength and Y, X, Y, Z, and that's what we're going to use today. So you know what to ask, guys. So we showed it to you just now. Okay, so do we have time to show the video? Shall we show the video?
No, we'll just say that go and look for this online behind the micro hardware, accelerometer on the microbit, and they have other videos too, and all their videos are amazing. All their videos are very high quality production.
Cool. Yeah. So this one basically talks to you about, it shows you how the microbit works in like the engineering of the microbits, how the circuits and
like how do you actually measure acceleration in electronics, right?
Okay.
So they go through that it's basically micro electromechanical system, MEMS. That's what it is. Yeah.
Well, this would be a very interesting video to watch if you're doing it with your kid. I mean, if your kid is interested in this, or if you are interested in this, it's a really interesting video to watch.
You're interested in science and engineering. Yeah.
Correct. Yeah. I think they do make good videos as well. So pause here for a second. Take a photo of this screen, right, and go look for it on YouTube. Yeah. It is on YouTube. Yeah. Okay. All right.
Google for it. Yeah.
Okay. And of course, this is like the data that you get from the accelerometer. Would you like to explain this, Amel? Yeah, is there something you can see on the screen?
So this is like real-time data that you can get from the accelerometer. So you can see there's an X, Y, and Z axis over there, and then the green color bar is the strength. So the strength basically is what is the reading return from the combined strength in the X, Y, Z axis. And what you're seeing here is what is happening as you take the microbit. If the microbit is stationary, that green bar is going to show about 1000, which is 1000 milli-G, which is about 1 G, which is the force of the gravitational force of us on Earth, right? If you go to the moon, if you go to the Mars, that's going to be different. But on Earth, it's about 1 G. And what happens is when you shake it, you see that it will spike up. That strength will spike up because it's experiencing free fall, it's experiencing acceleration that is not from the Earth gravitational force, but it's experiencing acceleration from someone, swinging it around.
Yeah. Hey, but talking about this is actually physics, right? Isn't this your weight? Like the gravitational pull of your body, isn't that your weight?
Yeah. So our weight is, you talk about the difference between mass and weight. So, you know, we learned it like mass is in kg and weight is actually a force, it's in newtons, you know, and weight is actually the result of the gravitational force of the planet on us. So our weight will be different on Earth, and it will be different on Mars, and it will be different on the moon, right? But our mass is the same, because mass is basically the collection of particles that make us. Yeah. But when it goes into a gravitational field, that's where we experience weight, and that's what the accelerometer sensor on the microbit is measuring.
Okay. Well, it's pretty cool, huh, guys? I think it's a very cool concept. It's like reaching into physics now. Okay, let's move. Anything else? I'm gonna move on here. Okay.
Yeah. Let's move on.
Yeah. Okay. So now it's like no. Okay. I don't think it's time for us to let you try and put the blocks together. So do we show the solution in the next slide? We do, right?
Yeah, we do actually.
Okay, so let's move on. So basically, we're gonna put this whole bunch of blocks together to get the program up and running. So if you notice the colors, okay, let's talk about the colors first, right? So if you are trying by yourself, right, the blue color blocks is obviously the basic blocks, and then just now I remember I talked about the logic blocks. Those are the green color blocks here, right? They look teal to me. And then of course this is under your input block because it's pink in color. The north, east, southwest ones are under variables. I don't know, they're way below. Where are they?
Under basic. When you got the basic block.
Bottoms? Yeah. Okay, so those are the 4 components in it. Okay, so anyway, you're supposed to put this together, and actually there's a cheat. You can see the tail, you know this thing is going to go in here. Come on, like you can tell.
Yeah.
Okay.
That's why block-based coding is so much easier, because you know you get
you can see exactly where it goes, right?
Yeah, that's right.
Okay. So this is one possible solution. When we say possible solution, I'm believing because there are other ways that you can actually do this. Off my head, I don't have any solutions now. If you do, feel free to share it on the Facebook page, man. And I think there's a Facebook page,
So what we are seeing here is that rather than use the on-shake event, we are looking for the event when the acceleration of the microbit is more than 1.5 g, right? So you see there 1500 or 1500. So when the acceleration of the microbit is more than 1.5 g, so we are not waiting for the shake event. We are not using the on-shake event handler. We want to be more sensitive, and because we get to decide what that number is, right? So if we find that 1500 is not sensitive enough, we can bring it down, maybe 1300. If we find that it is too sensitive, then we can increase that number to maybe 2000 or 2500. So then you have to swing harder, you have to be more violent in order to
exercise. Can be an exercise too, like with your arm. I don't know, but actually, if you put it too low, then it will always be on, right? Because any twitch will like basically turn it on already.
Yeah. So if you put it barely above 1000, right, any single twitch, and it will be activated. Yeah. So the control is up to you. If we use this solution using this conditional statement, then we get to really control when we want to trigger the event. So we're not dependent on the on-shake event handler code that is provided by MakeCode.
Okay, and then once the event is triggered, basically this show arrow thing is like it's just basic generic code that allows you to show a north, east, southwest. It can be anything. You can be showing numbers.
It can be anything. Yeah.
And then it clears the screen after it. So the screen is important because if you don't clear the screen, it's going to be there. It's going to be always on, right? So I'm sure.
Yeah, it's going to be always on.
So if you think about the problem that we have, right, you might need to turn it off. There might be there needs to probably be a button that allows you to turn it off as well. Okay, I'm going to move on from this screen. I don't think we need to look at it anymore. Okay, so this was what you were saying about the comparison of why we're not using the shake event, and we're going to use the power block, and we're always going to keep checking for the acceleration strength, right? So there are actually 2 ways. If you're really lazy and it's not lazy is a bad word. If you're really like just like, hey, I just want to get it over and done with, by all means use the shake block, man. Right, that will work too. Yeah. Okay, moving on, because we covered this a few times today. Extension. So talking about extensions, a way to add so this is like basically us telling them that we can add additional stuff to it to make it like cooler, like Wi-Fi module and entry module. Okay, I get it. Anything you want to say here?
No, let's go and add the extension actually. Can I take over the screen?
Yeah, sure, go ahead. I'll just leave it here.
Okay.
So I'm not going to show you how you add an extension. Yeah.
All right, so here we are at my screen. So we are going to be using the neopixel strip, right? And you notice that there is no code block that talks about the neopixel strip here. We actually have to add it into our project. And how do you get there? There are two ways. You can either click on the advanced and then click on plus extension, which is at the bottom here, or you can go to up here, the wheel, and you click on the extension. Okay, they're both two way works. And once you are here, you can see there's a whole library of extensions that you can add on. And we are going to be interested in the neopixel extension. You can see that colorful picture of the lights in the rainbow sequence. So click on that, and that will download and add the extension to your project. When that is done, you can see there is a new code drawer that is available to you, and that code drawer is called neopixel. Right. So let's try to get it working. So click on it. A whole bunch of code there. Let's do a very simple project. Whenever you are adding an external component, well, not whenever. Sometimes when you're adding an external component, you have to do some setup code. So the neopixel, you have to have some setup code, and this is a setup code over here. Do I have to do I have to zoom in a bit? Let me zoom in a bit.
I think it's fine. It looks fine to me.
Yeah. Okay, let me remove the simulator so that there's more space. Right. So you can see that this is a setup code. I put it on the start block. I have to tell my microbit, hey, I am adding a neopixel strip. It's going to be attached to which pin? Let's say pin P1. How many LEDs do you have? I'm going to say I have 20 LEDs, right? And so this is initialization code that tells the microbit that there will be a neopixel strip physically attached to pin P1, and that strip has 20 LEDs, right? You can actually have different types of strips out there, right? And then the GRB format is really dependent on where you buy your neopixel strip from. So you can see there are other options. And so you'll have to maybe experiment and see which one your light strip conforms to, which format it conforms to. Okay.
Oh, sorry. Right. What does that mean? Oh, sorry. The GRB thing. The GRB thing.
Different light strips from different people will have different format.
Okay.
Right.
Okay.
Like little engine, big engine. If you remember your computing. Back then.
Okay.
So
I get it.
It's just a different format from different manufacturers. Right. Okay. So we are going to do that same thing that we did with the accelerometer. So we are going to do that if the acceleration strength reading is more than, let's say, 170. Let's make it a little bit less sensitive, right? What I want to do is maybe I want to show a rainbow. Okay, I want to add a small pause so that people can see the rainbow. Let's say for half a second, which is 500 milliseconds. And then I'm going to clear my rainbow. Okay, and all these blocks are coming from the neopixel code drawer. The other thing that you need to be aware of with the neopixel is that sometimes you may tell the neopixel to do something, but it's not shown yet. So you need to kind of use the show command to say like, okay, I'm done setting the colors, now show. And that will actually make the change physically appear. If you don't have the show command, depending on which block you use, sometimes it will show, sometimes it will not. So there you have it. We have a very simple program. We want to show a rainbow color for about half a second, and then we clear it away. Let's download it and download it onto our microbit. In fact, before that, I'm going to pair my microbit. I have not paired my microbit yet.
Hey, you have a microbit connected to your computer now, like physical one.
I do?
As in, you're pairing. Are you connected to it?
I don't actually.
Okay. Oh, yeah, but anyway, I want to ask you a question about the pins. Yeah, so just pins, right? Because like you haven't shown them what the breakout board looks like, right? So maybe we can show them. I actually loaded the screen for the breakout board already, so later on we can talk a little bit about what those pins mean, because I think it's hard to visualize. Yeah.
All right. Okay. Let me download again first.
Yeah. Okay.
Let me download the program onto the microbit, and then I'm going to show. Okay. Give me a moment. Pin P1. Yeah. Okay. So I'm going to show my project cam.
Okay.
And let's take a look at it. Let's full screen it. So you can see here, this is the light strip. I'm going to try to move it very slowly to not to trigger it. I have my microbit here. Okay, I have attached, I'm using a special breakout board, a different breakout board than what we normally use. So that because it comes with batteries at the back, so it can be quite independent, right? And I've attached the neopixel to the breakout board, and my microbit is here. Oops, I've done it. So when I move the microbit and the acceleration that is seen by the microbit is more than 1,700, it will do that to the light strip. You can see that. Okay, so I've actually done the I've actually put this box here so that it's a bit darker so you can see it more clearly. Yeah. I've crafted up the light strip, right, with cardboard, and I have this here. So whenever I swing the, oops,
oh yeah, that's working. Yeah.
Whenever I swing the lightsaber around, that rainbow thing will appear, right? So that's kind of like, let me move this a little bit back so you can see. So yeah,
it's cool. It doesn't stay on for long because you set the time to clear the second.
Just half a second.
Half a second, yeah.
Yeah. So,
sorry, yeah. Sorry. Yeah. The breakout board that you're using is different from the one that we have on the slides, right? So yeah, so you might need to tell them that, yeah.
Okay, so I mean, let me just show you a variety of different breakout boards, and well, actually, yeah, different breakout boards and a variety of different neopixel strips, right? So this is one form of breakout board, right? If you can see that, you will plug in the microbit here, okay, and then you will plug in the light strip. Let me get a light strip. Oh, I don't have an easily accessible light strip, but let me show you a different one, right? So I have the same microbit board. Okay, I'll plug in the microbit here. Okay, and the light strip is attached to over here, right? So then this will be how you attach the light strip to your microbit via the breakout board. So this is one breakout board, this one. Okay, this is a different breakout board. This is a ring bit breakout board, and I use it because it comes with the battery holders, so you can power it independently in this project. Okay, right, and then I can plug in my like my light strip to the breakout board, and the code will work.
Yeah,
like how we want it to work. Okay.
The ring bit one looks a lot more compact. Yeah, looks a lot.
Yeah.
Ring bit is the car kit.
Car
kit, right? One of the car.
Yeah, it's called car kit. Let me show you a different breakout board. So not breakout board. Let me show you a different project, right? So this one I've used tracing paper to diffuse the light. I'm using 2 light strips, so 20 LEDs in total, and I'm using this breakout board with this microbit. I've already done the programming. I'm powering it from the USB cable. When I turn it on, this is the effect. And then I've animated it so that actually the rainbow will flow back and forth like this, right? So this is a light box project. Here's another microbit and breakout board and light strip. This here you see is also a light strip, right? This is also but it's in the form of a ring. But a ring is basically a linear thing that then becomes that becomes a ring.
Hey, right? This is the Lightbox project on the book, right? The book Lightbox project.
Yeah, this is the Lightbox project in the book.
Yeah, that's so cool, man. Like if you package it properly and nicely, you actually can put it on the wall and like it can be an art, interior design, deco kind of thing. It really is really good, huh?
Like so here's the light strip in the ring format. Let me show you the light strip in 2 other formats. I'm going to put this here first. Okay. So here are also WS2812 or neopixels, but they're in matrix form. Right? So they'll be coded at the exact same way. You'll be using the neopixel. You will be using the neopixel extension, and you will be coding it as if it's one long strip, but it actually gets converted into a matrix of sort.
Sorry, so
Right?
as long as they are from the
Yeah.
neopixel brand of like LEDs, they will just use the neopixel library, right? You don't have to that's the one that you will always use once there's a neopixel.
You will
Okay.
always use the neopixel library.
Well, look at those light strips, man.
Yeah. So there's a whole bunch of different light strips that you can. I mean, they're all neopixels. They come in different shapes. They come in strips. They come in rings. They come in matrices, and they're all programmed the same way, like this, right? And so what we did today was just a very simple program to build a lightsaber project with.
Sorry, I'm sorry to interrupt you again. How big is
Yeah.
the largest light strip that we can get? Like, what's the biggest? Like the one you showed is like a super big squarish one. How big can we get them?
Yeah. So that one is 256 LEDs.
Well, okay, that's really a lot. Yeah.
16 by 16.
That's the biggest.
No, I think you can go longer.
Okay.
But the main limitation is that when you have too many LEDs, the main limitation is power.
Okay.
Even for these 256 LEDs, which let me show you here, right? It's not recommended that you turn all of them on at full brightness at once. It's going to heat up really fast. It's going to draw a lot of power. Yeah, so it's not recommended that you power it up. And what happens is that
last longer, right? Yeah.
If you use the what?
Portable battery instead of using the AA batteries, you can use portable batteries to power it.
Yeah, it will last maybe a bit longer. But what happens is that a lot of this light strip, for instance, this one, they will ask you to power the LED separately from the microbit in order to get. The thing is, right now the power to the LEDs goes through the microbit, right? And the microbit has a limited. Is limited in how much current it can carry, right? And if you try to draw too much power, your microbit is going to heat up. It's not going to be good for it. So then, if you can power more LEDs, if you have independent power supply, and you power independently, and you're using the microbit just to control what color each LED should be.
Okay.
Right? So I don't think we've mentioned this, but the whole concept of WS2812 is that every single LED can be set to whatever color you want. They're all independently adjustable. They're all, they can all be changed independently from one another. That's the power of the NeoPixel.
Yeah, that's pretty cool. Yeah. So anyway, just to highlight one thing, don't use this to try and power your hydroponics set. I think I asked a question to Arnold yesterday when I was in the office. Yeah. So into hydroponics, this thing will not grow your plants. Yeah, even though they're quite
for hydroponics, you just want to get those dedicated LED lights that are they have the light frequency, the light wavelength is tuned best for growing plants, right? Yeah, you want to get those.
A lot more brighter, right? Like a lot more brighter than this.
Yeah, I think they will be cheaper.
Yeah,
they will be cheaper also. Because why? Because you don't need the LED lights to be individually adjustable. So actually, you are paying for the NeoPixel. You are paying for the fact that it's all programmable. There's a chip for each LED. There's a chip that is attached to it.
Yeah. Okay. Right. Okay. I think we should move on. Go back to the slides so that we can finish off. We didn't really cap off. We're almost time there already, time wise.
Yeah, it's almost time.
Okay, you got to share my screen. Is my screen up already?
Oh, sorry. Let me share.
Anyway, there's lag on the stream, so I wouldn't know whether you have to tell me whether it's up. I'm looking at.
Okay.
Is that
screen is up?
Okay, so anyway, guys, I was telling you guys about the LED strip and the breakout board. So I think I'll not show you the breakout board just now. And if you look at the blocks, the pins, right, those corresponds to those little colorful things at the bottom. Yeah. Anyway, we don't have much time. Buy your own breakout board. It's easy to play with, right? And buy our book and use our book and learn the breakout board. It's pretty easy. Or you can go online and YouTube it. It's also pretty much all there. Okay, so the colors and stuff like that. So in our normal class, we will always talk about the pins and we tell them what the different pins are. We don't have time for it today. If you want, you can ask us on a personal DM or you can reach out to us and we'll share with you. All right?
Yeah, reach out to us on social media.
All right. And then of course this is the lights. These are the LEDs and they talk to you about, hey, you know how the intricate details of the strip is do. When you buy it, you can actually take a look at it. I'm going to move on to all this because we have already talked about all this.
Yeah, so I mean, one of the extensions that I guess we actually ran out of time.
Sound one, is it?
Well, one is sound. That's extension number 2. Extension number 1 is to be creative in the light sequence.
Okay.
So it doesn't have to be a rainbow, right? It could be something else. Yeah.
Can I show them the code very, very quickly? Shall we do that?
Sure. Let's do a quick one. I know.
Let's show them the complete one with. Does it come with everything? Yeah, it comes with everything actually.
No. Yeah, it comes with everything. That one comes with everything.
Okay, let's show the everything one then. Yeah, the sound and everything. Yeah.
Yep.
All right, so guys, this is the code blocks for the ones that you can play sound. You can add an MP3 module. You can add a buzzer to your breakout boards, right? You can even change the lighting, do a rainbow kind of light show instead of like just one strip and things, and do one by one kind of thing. This is the code for you. So it actually allows the make code editor actually allows you to do a lot of creative stuff, as much as it's blocks and it looks like really kiddie and stuff like that, right? But actually you can create quite complicated programs with it, right? As long as you know what you're doing. Like I think adding sound, like really you can, like for example, you add an MP3 module, and if you're really building a lightsaber, right, you can actually download the lightsaber sound and it really look like a lightsaber. If you do it properly, obviously you don't use support. Then it'll be a whip. Then if you watch Bleach, you'll be the guy, that little girl with like the whip and stuff like that. Yeah, I don't know, man. Yeah. But anyway, this is code. It's pretty easy to do. If you've done coding before, if you look at it, you know what's happening. If you've never done coding before, you probably need to learn a little bit more before you understand this, right? Because it talks about functions, and then end up you have like other stuff in here that we have not explained. Yeah, probably need a little bit more basic. Yeah, but anyway, reach out to us. We can always share with you how this is done, or we can always share our code base with you. All right? Okay. Yeah. So this is what the buzzer look like. Yeah, you can buy it online as well. You can buy it at Simlim. The MP3 module looks cooler in this, and I've seen it before in the office. Right? In fact, it's in one of our up-and-coming kits, which you can get. Look out for it soon at Kino, right? Or online, right? Oh yeah. So so the buzzer is this, and it's easy to make. We have no time to talk about the buzzer, the pins, right? Let's not talk about it because it will take up too much time.
Yeah, I think so. Fine.
I think let's just cap off the lesson for today already, because I think if we do any more, it's too much of a rush. But I want to just say this: if you guys watching this video out there, if you are still streaming and you have not gone on to do something else because you've been sitting around just watching two guys talk about components, right? On a Sunday afternoon, right? Okay. Get your components from us. Get your components from Simlim, wherever. Like if you need help, go and DM us. We will hook you up with stuff. Classes, we always have a workshop available on Saturdays. You can come and join us. It's on our website. To find out about the ThinkerX program, you come and use our components. Let's join our monthly ThinkerX group and stuff. All of it is online, right? And I think that's about it. I hope you guys had time. Yeah. So I actually personally like all the questions you ask might be thinking like, hey, Ben's scripting it. Does he really not know this? Actually, some of the things I'm asking Amar, I really don't know. Like those engineering stuff, because Amar actually comes from a very strong engineering background, and I don't. Yeah. So actually I'm here. As much as I'm presenting him, I am learning a lot of stuff, and I hope you guys have learned as much as I have. Yeah, so
it's more way for us to discuss this and talk to each other, right?
Yeah, it's more and better. Yeah. So anyway, you're supposed to give them the QR code, right? For them to give you.
Yeah.
Is it this one or this one? Is it this one?
This one. Yeah.
That's two, right?
So if you're watching it, I guess in real time, or if you're watching it, afterwards, pause the video here and then take out your phone. Scan the QR code as if you are doing safe entry, and then go to the browser and give us your feedback.
Correct. And if you don't like people to have, for example, if this is not the kind of workshops that the style is not to your liking, you can always say, don't let two guys talk to each other on a workshop. I want to learn stuff. They're talking too much to each other. Man, you can put that in as well. Yeah. Unfortunately, that's our style.
Okay.
Yeah.
All right.
Yeah.
Okay, so that's all we have for you. I will have to try to figure out how to turn off this video.
Okay. Yeah. Anything, DM us, guys. Give us a feedback. Go to look out for the book. It's not out yet in the stores. I think it's nowhere. You have to get it from. It's under pre-order sale.
No, we are shipping it out now. It's up on gethacking.com. You can grab this copy of the book.
Yeah, it might be available in Kino.
So basically, what we did today was this project here, the Lightsaber project, and then I think I showed you also this is the Lightbox project.
Yeah, Lightbox project is cool, man.
Yeah, it's kind of cool. It's for those who are a bit more artistically inclined.
Yeah. Look at the colors, man. So pretty. It's teal, pink, and yellow, and like the kind of hue I like as well.
Yeah. So I mean, this rainbow colored sequence is really easy to do. Because let me show you. Yeah, because MakeCode has the show rainbow 1 to 360, right? And that will just give you an easy rainbow sequence. I guess we've ended the session. If people are watching, they're watching. They're not watching, they're not watching. I actually saw this thing, Ben, that I wanted to show you for the lightsaber. And
wait,
it was
I'm going to interrupt before. It comes with, if they want to buy the book, they can buy it. It comes with a kit as well, right? And there's like everything they need for every single project, and it's in the kit as well, right?
We have a Tinker kit, and that one will cover like maybe the first seven projects, like this one from this is a Tinker kit we have. It comes with a whole bunch of components that you can do like the first 7 chapters, and then what happens after that is the rest of the chapters are a bit more advanced, because we are talking about the light strip, motors, IoT. That one you'll need to buy the components individually, but we are trying to put it all together into so that if you wanted to do every single project in the book, then you can just buy a single kit to every single project. Yeah, but right now for the more advanced project, you will have to buy the components individually.
Okay, I think the kit's good enough. I think like if for me, if I'm doing the first 7 projects, which is going to take quite a bit of time already, I'll definitely get the kit. Yeah, so look out for it, man. I'm going to try and get it into the stores as soon as possible for everybody. Yeah, I'm actually looking at the StreamYard page, and it looks. I mean, like watching myself in real time is better than watching myself on the Facebook. 10 seconds later.
20 seconds.
Yeah, it's so crazy. I don't know, man. Half the time I'm like, this is like, that's not me. Yeah. Okay. Yeah. Back to what you were saying.
If there's still anyone around watching us,
man.
Where is that cola? No, maybe I can't find it anymore. It was quite fun because it actually was another lightsaber project from okay, give me 1 minute.
Is it neopixel stuff as well? Is it neopixel?
It was a neopixel. Let me think. It can't be from this help desk because let's try. What they do is actually I can't find the code right now, but what they do is actually they take the XYZ accelerometer reading, and they use that to color the light strip. So something like pixel. Let me see if I can do it. Pixel, set pixel color at 0. Okay, 2, and then we have color, XYZ color. Yep, great game blue, and you put it as because of the way the pills work. Like if it fits in, try it out.
Yeah, man. You get cute little response like reactions from your microbit and your components.
Okay. This code block is a little bit long.
Yeah.
So you have the XYZ, and that determines the amount of red, green, and blue for your pixel, and then that will be kind of a cool way. It's something like this, and you can continue working on it. But yeah, it looks something like this, so that as you swerve your lightsaber,
then it's going to have a delayed response and like delayed brightness and delayed color, or something like that.
So what happens is that it will set the pixel closest to the microbit to be the color of the position of the microbit, and then it will shift it down by 1. It will shift all the colors down by 1. Oh, hang on. You know what? I downloaded it. Here you go. Let's show it. Like, I think the Make It people will be like, why are they still broadcasting? It's already past 4 p.m.
Will they kick us out? I don't know. Maybe it's like the stream is not running anymore. Yeah.
I don't know, maybe, yeah. But yeah, I want to show this.
I mean, you spend 1 hour here already, so 10 minutes should be okay. Should be fine.
Okay, all right. So let's take a look at. I have to wait for the microbit to be visible. Hang on, I'll give it a moment for the microbit to be seen. Oh, wait.
There
actually, no. Something wrong with my. What happened is that
USB port.
Okay. Yeah. Okay, I'm gonna import it up to MakeCode.
Okay. Where can they find this code if they want it, man? Like where?
I was trying to find it just now, but I couldn't find it.
Oh, anyway, we can post it on our Instagram page.
So this is it.
Yeah.
This is it. And
okay, wow, there's so much more.
It's a bit more complicated.
Yeah. Oh, true set X.
Okay, so let's take a look at
+2.
this one.
Yeah. Okay.
So as I move my microbit around, you can see.
Oh yeah, I see it. Yeah, it does bubbling up, right? Is that meant to be the effect, the bubbling up effect?
Yep, that's right. So this is like so cool, this color, and then so if I move the microbit around, you can see it will glitter like that.
Okay.
But when I don't move it, then it will look like this.
Yeah, so cool.
Yeah,
it's like light play is like so interesting. You can actually like imagine you go around like during Lantern Festival and your lantern is actually a microbit with a neopixel and no one's gonna know. Hey, look at me, man. I assume my lantern like it just changes colors like that. It's like so cool.
You can totally build. You can totally build a lantern. Is the Mid-Autumn Festival coming up soon?
Sorry?
Is the Mid-Autumn Festival coming up soon?
I think it's supposed to be like very, very soon, right? I see mooncakes in the stores already. I don't know. It should be quite soon.
Oh, okay. Okay.
Yeah. By the way,
so you make a lantern out of the light strip, and then you can your with your kid, right? And then she can like, my lantern is better than your lantern. My lantern is programmable.
And you can always buy those paper like round ball lanterns and put this in there, and like it will look even cooler. Because I think they will come with craft ball lanterns that those kind of birthday parties and for weddings and stuff. Like those little paper lanterns. I think you have one in the office above you where you're sitting.
Yeah, but that one uses the smart light bulb from Philips.
Okay. But actually, it's the same, right? If you put this inside, it's like just fixing.
Yeah, it'll be the same.
Yeah.
Okay. All right.
Okay,
so let's
yeah.
All right. So we're gonna end the podcast on StreamYard, and then we'll see what happens on Facebook Live.
Okay.
Right, thank you.
Thank you guys for staying with us. Yeah, hope you have a good time.
Yeah, thank you, Amal. We'll see you around.
See you around, man. Thanks, Amal. Yeah. Bye.
Bye.